The topic of energy efficiency naturally takes us to also look at the systems that run our homes. For the majority of us, we're going to heat and cool our homes with fossil fuels, meaning heating through gas and oil systems and a separate AC system run by electricity. And that means we're serving ourselves up some really heavy-duty monthly utility costs. So to get out of that game, maybe there is a better technology to look at. That's where geothermal comes in. Geothermal combines heating and cooling in one system, as we will hear a lot more about. And what's really cool about it, it's environmentally friendly and is good for your own pocketbook. You will actually be able to get rid of some of your high utility costs, or at least sharply reduce them. I am super excited to have with me one of the real innovators in geothermal technology today, Kathy Hannun. She is the founder and president of Dandelion Energy. Dandelion installed systems throughout the state of Connecticut, New York, and all the way up to Massachusetts. So with that, welcome, Kathy.
Thanks for having me, Sabine.
Thank you for coming and giving your insight to our audience today. I'm super excited about this conversation. I want to start with by asking you a simple question. Why geothermal?
I wish the question was more, why not geothermal? Because it has so many benefits that it can offer for homeowners. Just to name a few, it's the lowest cost heating and cooling you can get once you have a system installed. And the reason for that is the system is actually using electricity to move heat energy from the ground into your house to warm it in the winter, and then from your house into the ground to cool it in the summer. And so most of the energy you're using is just free energy you already own in your own ground. And it's hard to get more cost effective than that. Another reason people love geo, it's very quiet. There's no noisy outdoor air conditioner. So in the summer, you don't have the eyesore of an outdoor compressor. You don't hear that buzz constantly. It's just peacefulness in your backyard. There's no emissions from the system. So people who really want to maintain great indoor air quality for themselves and their families love this type of system because there's no, risk of carbon monoxide poisoning. There's no fumes, and it generates very steady, even heat. It doesn't dehydrate the air as much as the typical furnace. So I could go on, but there's a reason that historically geothermal systems have been luxury systems, and now with technology advances and policy as it is today, for the first time, they're actually cost effective to buy. Because while they've always been very cost effective to run, one of the big challenges in the past has been they've been very expensive to get installed. So that's what's starting to change for the better.
Very interesting. How did you get started in this whole world?
I got started on this project while I was actually working at Google's X Lab, which is a part of Google that looks for big opportunities to use technology to make a real impact. And what captivated my attention about the potential of geothermal is heating emissions are one of the biggest sources of carbon emissions in the US. And it just seemed like geo, which is actually a proven technology, it's been around for decades, it's widely used in Sweden. As I mentioned, it has all these great properties. It's the most environmentally friendly way of doing heating and cooling. And it just made me ask, why don't we use this in the United States more than we do? And the more I studied that question, the more convinced I became we should be using this at greater scale. And there are real things that we can do to make this more cost effective for homeowners and easier for homeowners to get it installed.
So with that, tell me, what are the components? And don't shy away from also mentioning where Dandelion is quite frankly different than other geothermal installers, because you really are a step ahead of many. So
Sure. There are two main components to a geothermal heating and cooling system. One component is called the ground loop. And this is essential. So what you do is you get a drilling rig, to drill a 4 to 6 inch diameter hole in your yard. And that hole is typically 300 to 500 feet deep. And a typical home will have one or two of these wells, but it scales with the size of the home. And you put essentially two pipes next to each other that are connected at the bottom into that hole and fill them with water. So these pipes are just circulating water through the hole. And then you fill the hole up with grout, which is just a way of keeping it all closed and no air in the hole. And then you connect that ground loop into the house, where you put a geothermal heat pump in the basement or utility closet, or wherever your furnace was, is typically where it goes, so that the ground loop can send water into that heat pump. And the heat pump is specialized in taking heat out of that water, concentrating it so it's much hotter, and then using it to heat the air in the home in the winter. And then in the summer, the whole thing reverses, and the heat pump is specialized in taking heat out of the air in the home to cool it, and then putting that heat back into the water where it's cooled down by the ground. The ways that Dandelion differs are several, but some of the biggest ones, the most visible ones, is one of the first things we noticed, because it's very obvious, when we approached the problem, was the drilling rigs that were being used to put these heat wells, if you will, into homes in the Northeast, were water well rigs. And that's just because those are the rigs that are around to serve homeowners. But water well rigs tend to be mounted on giant truck beds, and many yards are not big enough to have a water well rig back up onto the yard. Even if they are big enough, often it is a very messy business that homeowners are not thrilled to undertake.
I will be the first one to say that, because having done it, I can tell you it floods out your entire property, and not only water, but all this gunk that comes out of the ground. And then
That's right.
it's material you can't grow grass in, nothing grows in it basically. It's ground up rock effectively, and you got to figure out a way to scrape it off. So there's another hidden cost right there in terms of landscaping
That's correct.
in the old system.
And often your neighbors don't like it either. There are like so many problems, and it's good to talk to somebody who's experienced it firsthand, because yes, you understand exactly what I'm saying. So, what we did is we went to Sweden, because Sweden is one of the world leaders of geothermal adoption. It's in about 20% of homes there. They've been doing it for over 50 years. They're very good at it. So we looked at how do the Swedes do this?
Yeah.
And they have this really small, compact, track mounted, which means it doesn't create ruts in your yard, drilling equipment. They have these specialized dumpsters that collect all that gunk and material so it's not going on the yard. They keep the site super clean, and the equipment fits in tight places, and it's also much cheaper. So it's like, they've had so long to work this out that they've really figured out how to do this. And basically, the Swedes mentored us. They taught us their ways, and we translated the way they do it in Sweden to the equipment now that we use here in the US, and it's much more friendly to homeowner yards. So that's one big difference. And then the other thing that we've done is
in there. That is huge. Let me just say, everybody who's listening, this is what makes geothermal possible in smaller yards, landscape properties, and existing homes. It's like the fundamental, most important thing. There are other things that we're going to hear about, I'm sure, but to me, it starts right there. So it's just dynamite that existing homes can now have geothermal installed on their properties.
Yes, and it's much less disruptive, exactly. And it's been a big deal for us too, just because before we were using this equipment, we had to just disqualify about half of the homeowners that would come to us, because we just physically could not even fit a water well rig on their yard. So it's made a big difference, and I think allowed the homeowners to have a much more positive experience getting those ground loops installed. And then the other thing that we encountered was the geothermal heat pump itself. It looks kind of like a furnace. It goes where the furnace was. It does both heating and cooling, as you mentioned.
Mhm.
The heat pumps on the market were not necessarily optimized for existing homes in cold climates. And what I mean by that is when you build a geothermal heat pump, or any heat pump for that matter, you have to decide, is this heat pump going to be optimized for heating a house? And then it can also do cooling, but it's not optimized for cooling. Or is it going to be optimized for cooling, and then it can also do heating, but it's not optimized for heating?
Mhm.
And because I think because the industry in the US really grew up in the Southeast, the heat pumps available, the geothermal heat pumps available on the market are largely optimized for cooling. So they're very good air conditioners. They can also do heating perfectly well, but they're optimized for that air conditioning mode. And of course, for homeowners in cold climates like New York, Connecticut, and Massachusetts, you really want to optimize for heating. So we did that. It allows us to do many things that are useful. One is very high efficiency system in heating, which is what, 80% of the energy used in a climate like the Northeast will be heating. It also heats more. So just like, produces more heat for the given unit. And we've designed the system to be able to produce hotter air than a typical heat pump. And what that allows is that our heat pump is more compatible with existing ductwork in the home.
Mhm.
Heat pumps tend to need larger ductwork. And ductwork, I should say, are the like channels that air goes through to get inside your house. So if you have vents on your wall, those are like ductwork coming to a vent to put heat into a room.
Mhm.
Those channels tend to be smaller for furnaces than they need to be for heat pumps. And so having a heat pump that can produce warmer air, it just lets the home work better with a geothermal heat pump. So those are a few of the main changes we've made to make it easier and less expensive for homeowners to adopt this
So
technology.
that's your proprietary equipment now.
That's right. Yes. Yep.
Okay. And in terms of from the beginning, sizing up the whole system, specking out what needs to go and what capacity you have your own in-house engineer.
Yeah, one thing for any homeowner considering any type of heat pump, be it geothermal heating and cooling or air source heating and cooling, it's so critical to get your contractor, like make sure that person is really measuring your home and how much heating and cooling it needs. This happens before the installation to figure out what size heat pump should be in the home. And it's an absolutely critical step to get right. And yes, we do have our own team of engineers who design systems for each home to make sure that we're sizing it appropriately for the home and that it will, work optimally for that homeowner.
And I have to add, just as a builder, developer, and for that matter, homeowner, having any installation under one company puts you miles ahead of the game because the blame game is then not there. Nobody's blaming the driller, a third party, or a equipment producer. It's all under one umbrella, and that in and of itself is immensely valuable because it identifies issues way quicker and resolutions come about way quicker also. So I always in my own life, I look for that kind of holistic approach because I know, having gone the other way many times, it, anything else just leads more complication and more blame game kind of games at the end of the day. So
Yeah, I mean, to your point, one of the things in the past that has made geothermal heating and cooling installation complex is that, of course, it does have this ground loop component, which no other type of HVAC system has. And so, as you're saying, like the typical arrangement was you would have to find a specialist who could do geothermal, and then that specialist would find a driller, a water well driller typically, who they could subcontract the ground loops to. And that just becomes a complicated set of companies to manage for, especially like for a typical homeowner, right? You don't want to be a general contractor. And so you're absolutely right. One of the things that Dandelion wanted to do from the beginning, just to make it simpler for homeowners. Let's just do it all as one company. We'll get the permit, we'll do the design, we'll get the permits, we'll do the drilling, we'll do the installation, we'll get the rebate for you. Let's just like take care of it, because a typical homeowner, they're not interested in being a general contractor. They just want to deal with one person.
I don't blame them. Why would they want to think about a driller, an excavator, an installer as somebody inside the house to hook it all together? So having it in one package is really the ideal. And yeah, so I think you're 100% on the right track there. Are there homes that don't really work in terms of their fundamental heating setup for geothermal?
Yeah, it's a great question. I mean, unfortunately, there are a lot of homes in the Northeast that use radiators for heating, and there's steam radiators, there are baseboard radiators, there are many different types. There are cast iron radiators. In general, radiators are not a good fit for geothermal heating and cooling, or any heat pump for that matter. And the reason for that is that the temperature of the water that's required to circulate through those radiators to give off enough heat is so high that a typical heat pump, it just cannot heat water that hot efficiently. Or in the case of steam, like you just can't get there. But even when you can get there, it's just not very efficient. So, and you don't get air conditioning. And I think
Yeah.
these days, especially, a lot of homeowners really value that air conditioning element to the system. So what we do is we only offer geothermal heating and cooling systems for homes with ductwork. That's forced air heating and cooling. Some of our homeowners decide to get forced air installed and then get geothermal, which works perfectly well.
Yeah.
But that's the major limitation that we see.
It's actually a good moment to then rethink your entire infrastructure and say, okay, I wanted air conditioning for a long time, so let's
Yeah,
really put it together and make it one complete package. It's a perfect opportunity, really.
it is.
The first time I installed the geothermal, this was way before Dandelion even existed. I was told, because it is such a woo-woo new system, completely not true, but we need to have a gas backup is installed just in case, because we really are not quite sure if we can trust the system. Was subtext to that recommendation. I subsequently did, but I think that's kind of obsolete thinking and unnecessary, right? It just adds to cost.
Yeah, so the huge advantage to geothermal in a cold climate is because you're getting heat from that ground loop that's buried hundreds of feet in the ground. Hundreds of feet in the ground doesn't care how cold it is outside. It's gonna like remain the same temperature year round, which is the whole advantage. So there's absolutely no need for a backup fossil fuel heating system. And in fact, Dandelion's installed over 3,000 geothermal heat pumps in the states you mentioned over the past almost 8 years now. And we've never installed a backup fossil heating system, and it's been totally fine. So
That is
yes, I think that is a great thing about Geo, and it differs. I mean, a lot of people who get air source heating and cooling do decide to do that backup because the amount of heat an air source heat pump can produce when it's super cold, and the efficiency at which it can, like with which it can produce that heat, does drop off when it gets really cold. It's, you can do it without backup too, if you're willing to.
Explain this a little bit more for our viewers. There are ground loop systems, so that's what Dandelion does. They go deep into the earth to bring out the constant temperature of the earth and use it in your heating and cooling. And then there are air-to-air systems. And there
That's right.
are some people that swear by air-to-air.
Yes.
The verdict is really out whether they perform in cold climate environments. And as Kathy just mentioned, there are other negatives that come with an air-to-air system. So that sometimes they get lumped together, these systems, when in fact they're very different in nature, actually.
It's two different ones, and I want to make sure that no one thinks I'm disparaging air to air, because it can be a great option for homes, and I think there is definitely a place for it. It's the trade-off. Like, For air to air, typical air source heat pump, on the plus side, you don't need to get a ground loop. So there's no dealing with drillers. It's less expensive up front because you don't have to pay for the ground loop. But on the con side, it doesn't work as well when it's super cold. And some people are fine with that, and some people aren't. So it's like there are two different options, right? And different ones make sense in different situations. But yeah, one of the big advantages of Geo is that this ground loop is a one-time investment, and then it lasts like forever. So the ground loop should last as long as the home. And so once you get it installed, from then on, your home can take advantage of this like very cost-effective, very efficient source of heating and cooling that doesn't really depend on the weather outside. It's independent.
And one more, I don't want to get too technical here, but at the same time, you need to tie the system into an existing electrical panel. How does that look for a heat exchanger from Dandelion?
Yeah, thank you. So I didn't mention this before, but it is true that for any heat pump, it will need to be served by electricity from the house. And some of these older homes that we serve, they don't have enough capacity left on their main panel to be able to support electric heating and cooling, meaning any type of heat pump. So one of the other things we thought about in our proprietary heat pump was how can we make it less likely that a homeowner will not have space for this on the main panel. And what happens if a homeowner doesn't have space is you need to do what's called a main panel upgrade, which is doable, but it tends to be rather expensive. So these upgrades cost anywhere from $5,000 to $9,000, and you have to coordinate with the utility, which can take a long time. So it's very good to avoid it if you can. So what we did was we designed a heat pump that needed about half of the electrical service that a typical heat pump would require, because we found that made it much less likely that you would face that barrier to installation. It's just another thing we could do to make it more cost effective for homeowners to get these systems installed.
Yeah, I think this is a really important point. And talk about maintenance. What's there to maintain in a system?
So on the ground loop side, it's virtually maintenance free, and that makes sense when you consider what a ground loop is. It's plastic pipe buried in essentially like cement, buried in the ground. So it's just like very stable, very inert, not gonna need maintenance. So that's great. And then on the heat pump side inside the home, again, like one of the big advantages to Geo is all the equipment is inside the house. So you're not having an outdoor, for example, air compressor that you would have with an air conditioning system that has to get leaves in it in the fall, then iced up in the winter, like that. It's just when you're not exposed to the outdoor environment, less maintenance is required. But there is some. So we recommend our homeowners do regular filter changes, just the air filter in the system. And then, many of our homeowners, like you would with any HVAC system, get annual or every other year checkups by a qualified technician just to, look into it, make sure everything's going well.
Yeah, absolutely. One final question. As you know, I'm a big buff about real top quality indoor air. And so for the most part, as we are insulating more and more and we're creating this cinched in kind of environment, and we have cleaning products and mattresses and paints off gassing and all this other toxic brew that we're now keeping in, I am a big fan of ERV system, energy recovery ventilation units, to constantly make sure that we are actually breathing filtered air. And sleeping in, spending out, working in, air quality is just so important. So between the geothermal and the ducts, can you in fact, somewhere in there, install an ERV system to just make sure that the air is constantly being scrubbed?
Yeah, you absolutely can. And some of our homeowners do decide to do that. So there's no limit when it comes to, yeah, it's compatible with an ERV.
Perfect, because those must be the ones that are watching SHD Living by the minute because we talk about it a lot. Our hosts talk about these things a lot. It is such an important part that a lot of people are missing. And as we're talking about infrastructure in our home, I think it's another really big component to be aware of. And when you do it, just do it.
Mm-hmm.
So in closing, I just want to open the aperture just a little bit more and just tell our viewers that geothermal is not some cottage industry. In fact, it is also being installed on very large commercial projects now. In Connecticut, we are seeing schools that are putting in geothermal systems. In New York, I'm aware of moderate and low-income housing complexes.
That's right.
Receiving geothermal systems. And even in New York, the drilling is so precise that imagine big old century-old apartment buildings with hundreds of units are now being retrofitted with geothermal wells and geothermal systems. I mean, the infrastructure from water pipes, sewer pipes, electrical systems, trains, all of that underneath a building, and yet it's possible to do this. And just the next time you're visiting New York and you find yourselves on Fifth Avenue, I encourage you to dip into and visit St. Patrick's Cathedral. It's a beautiful building. They renovated a few years. And when you step in there, notice the air quality. Notice the perfect temperature. It's heated in the winter and cooled in the summer. It's really a beautiful experience just to be in the space. And guess what's running it? Geothermal systems all the way. So with that, I want to thank Kathy very much for her expert insight and time today, because I really want to encourage everybody to think carefully if geothermal is in your future. If you can make it work out somehow, it is, in my experience, one of the quintessential shifts in the way that you experience your home and living in your home environment. So again, thank you very much, Kathy.
Thank you so much.